Hey, how's it going, students? Today, everybody will want to pay attention because I'm going to teach you how to play winning poker. So you can all go to Vegas and win the World Series of Poker, and then you can just stop going to school. Woo! Okay, but first we have to do an exciting probability lesson. So if you want to follow along with me, I'm going to click this. It is a PowerPoint for this lesson. Enable editing. I'm going to punch F5. Boom. And what we're talking about here in normal distributions is this curve, right? This is a hypothetical distribution created by statisticians because they have nothing else to do. But it is important. And I want to talk about the actual curve for just a second. The baseline of the curve is equal to 100% of a distribution of values, right? Just like we were working with standard deviation. When you had a column of numbers, that is a distribution of values. The two halves of the distribution or the curve are equal to each other. The mean is dead center in the curve or the distribution. And most importantly, the distribution can be described if we know the mean and the standard deviation, which is the whole point of this lesson. We're going to be looking for areas along this baseline, specific sections of the curve. So I want you to think about this curve. Remember what I said, the baseline is 100% of a distribution. But I want you to think of it this way. Here's the mean right in the center. Remember, this side is equal to this side, either side of the mean. So I want you to think of it this way, that you're starting at the mean and going out simultaneously in both directions to find, exactly half of the curve this way and half of the curve this way. This will help you with conceptualizing the problems, which is really the only tough part of this lesson. The concept of what you're doing is going to take a little getting used to. Okay, here are two identical normal curves. Notice how one of them says this is z-score language, which I'll get to more in a minute. The other curve is actual data, right? In z-score language, the mean is equal to 0. And, one standard deviation above the mean or to the right of the mean is just equal to the number 1. But let's see, the values in actual data, like age, for example, the mean at the center of the curve is 20 years old. And the standard deviation is equal to 2. So if we move or add one standard deviation above the mean, we're going to move from 20 to 22. So the point of this whole graphic here is to show you that this shaded area in z-score language between the mean of 0 and 1 standard deviation is identical to this shaded area between the mean of 20 years old and adding 1 standard deviation, which brings you to 22. Okay? Totally confused yet? Right on. I told you it was going to be weird, but it'll get better. The point of this lesson is we're just going to calculate z-scores. And once you have a z-score or a precise standard deviation above or below the mean, then you have to look into the appendix, which is provided in the lesson this week, and find what the corresponding value is for that. So look here on the bottom. If you calculate a z-score of 1.48, you're going to look down the z column for that value and then directly across to the right. And you have to choose, whatever corresponding value from column B, C, or D. And here's an example, right? This is the table of corresponding values, or the appendix, and it's many pages long. But every page has this header on it, right? So here's a section, and this page up here has the identical headers at the top. So I just want to show you this first, right? The Z column is on the left, and then you have three other columns, right? The proportion in the body, proportion in the tail, and the proportion between the mean and the Z, right? And that all is talking about areas under the curve. So if we found, if we calculated a score of 1.48, then we would go down the Z column until we found that, and then just move to the right. And depending on the language of the question, you'll know which of these three numbers to pick as the answer. Wow. Okay, moving on. This is how you compute Z-scores. Super easy, right? Z equals the value minus the mean divided by the standard deviation. Let's see. The Z is the score that you calculate. X is the value given in the problem. The X bar is the mean, and the small s is standard deviation. Okay, all three of these lower items will be given, and you have to calculate the Z-score. Pretty simple to do that. The appendix, again, located in corresponding values, as I told you, to the right of the Z column. B is the body, C is the tail, and D is, the proportion between mean and Z. And I know you're probably all just kind of shaking your head going, what in God's name is this guy talking about? But I promise you it will become clear. Okay, here's the first example. Now, the second most important thing in how to do this is to read, the language of the problem. So here's the first example. Find the percentage of the data that falls between 0 and 2.25. I'm not even having you calculate a Z-score for this one. I'm just giving it to you. It's 2.25. But the key word here is between. If you see the word between in any problem, then you know automatically that you're going to look in the D column. That's the only place where between appears. So if you see a problem that says something that falls between 2 points, boom. When you calculate the Z-score, you're going to go directly across to between mean and Z. That's the easy one. So if I look in the appendix for 2.25, the corresponding value in the D column is 0.4878. Okay, so let's just check that out. Oh, can't do it. Dang it. Trust me on this one. If you go to the appendix and scroll down until you find 2.25, and you go from there directly to the right to the D column, you'll find 0.4878. You can use this as the answer. You can change it to a percentage, 48.78%, whatever is most comfortable for you. So again, the key word in this question is between. Between means look in column D. So with a Z-score of 2.25 and looking in the correct column, the answer is 0.4878 or 48.78%. Awesome. Boom, here's another example. What percentage of people in the distribution are taller than me if I am 69 inches tall? Okay, so in the problem, it's giving you the value, which is 69, And it's asking you what percentage of people are taller. And it's giving you the mean, which is 64 inches, and the standard deviation, which is 4 inches, and you have the value. So all you have to do is plug in these values to the problem. Here's the formula. Z equals the value minus the mean divided by standard deviation. The value 69 minus the mean 64 divided by the standard deviation 4. So it turns out to be 5 divided by 4 is 1.25, and that is your z-score. Okay, find the corresponding value from the appendix. Now, yeah, you got a z-score of 1.25. You know what that equals? 0.1056 in the tail column. Right? Remember, there's a tail, a body, and a between mean and z column. You know, why am I using the proportion in the tail in column C? You know, first, because the language of the problem. You know, what percentage of people are taller than me, which means greater than me, which means beyond 69 toward the tail. And now I'm going to tell you the most important thing to do when you're working these problems. Every time you read a problem, I just think it's vital that you draw a curve, put the mean in the center, and put the value where it's supposed to be. You know, 69 is greater than 64, so it's to the right of the mean. And then it says what percentage of people are taller if I'm 69. So this part of the curve is what I want to shade. And then it kind of shows you that, you know what, you're looking for the tail. Remember, when we looked at the slide and looked at the curve from the mean going out both directions, it was going out towards the tail this way and going out towards the tail this way. So this is the tail of the curve. And if it's everything above 69, then it's the area in the tail. Okay? So you get a z-score of 1.25. Look in the tail column. The answer is 0.1056 or 10.56%. Boom! Okay, so your assignment is the probability problem set. And again, I'd advise you to draw the normal curve for each problem. Oh my. I will do the first set of problems with you or for you in the problem set. So look for that video. And oh my. Oh yeah, I forgot to tell you. A deck of cards when you play poker is 100% of the distribution, 52 cards. Okay, you can mentally calculate how many cards are left in the deck each time cards are laid down for all players when you're playing poker, and have an edge on people when you decide whether you want to stay in the hand or raise or call. So if you want to know more about that, come into the office hour and ask me or send me an email or whatever. But one student a few years ago told me after this lesson that she went home and cleaned out her whole family over the weekend. So hopefully she didn't tell him that her professor taught her how to do that. Okay, so I'll see you in the problem set. Bye-bye.